Okay, this will be our last video for the prerequisite packet. So 43, you need to solve this system. I'm going to solve this using the substitution method since this is already solved for x. So I'm going to take this whole expression and plug it into the top equation for x. So then I will rewrite the top equation as 2 times x, which is now this expression, 2y plus 6 plus y equals 7. And then you can distribute 4y plus 12 plus y, and obviously solve for y. And you would get y to be -5. Then you'd have to plug this back into either equation to get your x. So then x would be -4. So you write it as a coordinate pair, -4, -5. For this one, you want to use probably elimination. You want to eliminate a variable. Since these are opposites, I'm going to eliminate the y variable. So I'm going to multiply the top by 2 and the bottom by 3. You just flip-flop those. You multiply the 2 to the top equation, 8x minus 6y equals 18, and multiply the 3 to the bottom, 21x plus 6y equals -18. And you notice that the y's will cancel their opposites. And you just add them straight up and down. You get 29x. This side you get 0. So x is 0. And then plug it back into either the top or the bottom. It doesn't matter, but you get y to be -3. So your ordered pair is 0, -3. Now, this is a word problem using elimination method. Joe stops at a burger restaurant on Monday and orders 1 medium fries and 2 small hamburgers for a total of 620 calories. So if I were to write that, I would probably use letters like F and H. So 1 fry plus 2 hamburgers is 620 calories. On Tuesday, he went back to the restaurant and ordered 2 medium fries and a small hamburger for 820. So 2 fries and 1 hamburger for 820. And I would use the same method I used for 44. Probably, I don't know, I'm going to get rid of the F, so I'll multiply this by -2. So -2F minus 4H equals -1240. And then I'll rewrite that bottom equation. And then you can just solve. This would eliminate the F's. You'll have -3H equals -420. So a hamburger has 140 calories, and that's the answer to the question. 46, again, using elimination method, I might multiply this by, I want to make this top a 4. Actually, I want to make it a -4. So -4x plus 8y equals -6. And then my bottom equation, I'll just rewrite it. If I add those up and down right now, notice what happens. This side cancels to 0. Everything is 0. This side cancels to -2. This is an untrue statement. 0 equals -2. So this has no solution. If you have a system that has no solution, what you really have are 2 parallel lines. The lines aren't intersecting. When they intersect, they create one solution here and here. So this is 2 lines that are parallel. They're never intersecting. 47, graphing inequalities and then shading the solution. You graph them like you would a line. Like this, think of this as just x equals -3. If you went back to the first part of the videos, x equals -3 is a vertical line at -3. 1, 2, 3. This one would just be y equals 4, which is a horizontal line at 4. Goes that way. And then this is the line like y equals 2x minus 2. So I'd start at -2. And I go up 2, 1, 2 over 1, up 2 over 1. You want to go all the way until like they intersect. Down to 1. Now, this one has, notice this has a line under, this has a line in it, so I made it solid, but this does not, so I'm going to make this dashed. Now, for this x equals this line right here, you want to be greater than -3, so you would be shading this way for that vertical line. Y is less than 4, that's this line right here, this horizontal line, you want to be shading below. For this slanted line, y is greater, which means you would be above it. So notice where the 3 are intersecting. This area right here is what you would darken. And that's where all the solutions lie to those 3 system of inequalities. So let's do that again for this one. This is a combined inequality. X is between -2 and 5. So you actually are drawing 2 lines. You're drawing one at -2 and then one at 5. And if X is an answer between them, obviously you would be shading in between them. Now I'm going to graph this one, but I have to solve. So this would be 3y is less than -x plus 6, and then divide by 3. Y is less than -1/3 x plus 2. So if I graph that, I'm going to start at 2. I'm going to go down 1 over 3, down 1 over 3, or up 1 over 3. And again, this would be a dashed line. So for this last equation, I want to shade less than, I want to shade below it. So again, where do all the intersections occur? Right inside there is where they overlap. You could use like 3 colors to help you out. Okay, now we're into radicals and rationalizing. So if you see a square root symbol, the way that I do it is I like to do factor trees and break it down that way. So 20 is 4 times 5, and 4 is 2 times 2. For every 2 of a square root, you pull out 1. Same with x's. So this is x cubed. That would be like having 3 x's, but for every 2, you pull out 1. And y to the 4th would be like y. So you have 2 pairs of y's, so you're going to pull out y squared. So what's the only thing left underneath? A 5 and an x. And that's your answer. This one looks complicated. This star means multiply. You are allowed to multiply radicals together as long as their indices are the same. So you can multiply what's on the outside together. 5 times 3 is 15. And then square root of, and I'm going to kind of break this down as I do this. 30 is the same as saying 3 times 10 xy. 12 is 4 times 3. Again, you can use anything. I'm just going to break it down. Times x to the 4th y. All right, so let's see if we can grab 2 pairs here. So 3 and 3 can be brought out. So we're going to multiply the 3 with the 15. I'm going to make a little times 3 here. The square root of 4 is 2. So I'm going to bring a 2 out. And then I have an x and an x to the 4th. So I have 5 x's. So that means I can pull out an x squared and still be left with an x. And then y times y, I could pull out a y. So let's see what I have in front. 2 times 3 times 15 is 80. X squared y times the square root of, there's still a 10, and I still have an x. Again, different ways of doing this. You could have multiplied it all out and then broken it down like I was doing over here. I'm just showing you one way. These are multiplying radicals. So for this, you want to actually FOIL it. 4 times 5 is 20. 4 times -2. You can only multiply what's on the outside with something on the outside. So this is just -4 square root 2. Inside this would be +5 square root of 3, not square root 15. This is not under a radical. But these two are under radicals, and you can multiply them together. So that'd be negative square root 6. Nothing combines, so that's the end. Here is a cube root. Cube root means for every 3 you pull out 1. So 24 is 8 times 3, and 8 is 2 times 4, and 4 is 2 times 2. So look, there's 3 2's right there. So you're going to pull out one of the 2's. The 3 will stay. A cubed means that you have 3a's, so you're going to pull out 1. B to the 5th means you do have one group of 3 b's, so you're going to pull out a b. And then you're going to be left with b squared underneath. So let's see what we have left underneath. Don't choose this 4. That was already part of the 2's. Choose this 3 and the b squared. and then put a little cube root, and that is your answer. Radicals, you don't want radicals in the denominator, so we want to get rid of that. Usually you multiply the top and the bottom by that radical, but a trick is if these two radicals can reduce it. So 5 can go into 10 2 times. So 2 square root of 2 over 3 is the answer. Again, don't want radicals in the denominator, but this radical, notice this is different from this one. This is multiplication, this is subtraction, so this is a binomial. In order to get rid of a radical in the denominator that's attached through a binomial, you have to use what's called the conjugate. So the conjugate of 3 minus square root of 2 is 3 plus square root of 2. And then you're going to FOIL the top out. You would get 12 plus 4 square root of 2 plus 3 square root of 3 plus square root of 6. Nothing can combine there. The bottom, you can FOIL it, but really you only have to do the first times last because the O and the I part will cancel. So 3 times 3 is 9, and square root of 2 times square root of 2 is square root of 4, which is 2, and then the negative and the positive make a negative. So your final answer is that top right there, all over 7. All right, last but not least, some i's. If you remember, i's are imaginary numbers, complex numbers system. Just to go over all these with you, I is the same as saying the square root of -1. I squared is -1. I cubed is -I. And I to the 4th is 1, okay? When I ask you to simplify, your answers will be in the form of either I, you don't ever write I squared, you would write -1. You don't ever write I cubed, you would write -I, and then I 4th is 1. These are the ones that I highlighted are the ones that you will always write as a simplified form. So when I see I to the 38, what does that mean? That means I have 38 i's. Well, for every 4 of them, it makes 1. So let's divide this by 4 and find out what our remainder is. So 4 goes into 38 9 times with a remainder of 2. Well, that's what this is equivalent. This is equivalent to I squared, but I don't want you to write I squared. I want you to write what I squared is equivalent to, which is -1. That is your answer. Same with I to the 100. So if I divide by 4, again, why am I dividing by 4? Because every 4 i's is 1. So 4 goes into 100 perfectly 25 times with a remainder of 0. What does that mean? Well, that means that's like I to the 0 or 1. It's equivalent to I to the 4th. And that would be your answer that you would write. 57 is now just foiling again with i's. So the thing that happens here is it's foiling like you would. 4 times 5 is 20. 4 times 3i is 12i. -2 times 5 is -10i. And -2i times +3i would be -6i squared. But I squared is equivalent to -1. And a -1 times a -6 is really +6. So you can now combine your like terms. 20 and 6 make 26. 12i minus 10i is 2i. And that is the final answer. Last few. So 4 over 3i, just like radicals, you don't want i's in the bottom. So to get rid of them, you multiply the top and bottom by them. Whatever you do the bottom, you always got to do the top. So the top becomes 4i. The bottom will become 3i squared, but I squared is equivalent to -1. So this is just -3, so that's your final answer. 4i over -3, or negative, you can put the negative on the outside. If, however, this is a binomial, like this was not, this was a binomial, you have to multiply by conjugates like we did up here. Same idea applies. So the conjugate of 3 plus 2i is 3 minus 2i. You have to do the same to the bottom, the same to the top. And distribute. So 6 minus 4i. The bottom, again, you just have to do first times first and last times last. So that would be 9 minus, there's always a minus, 2i times 2i is 4i squared but I squared is a negative, and a negative times a negative is positive. So this is really positive 4. So 9 plus 4 is 13 on the bottom, and 6 minus 4i on top. Now you can write it like that, or some books want you to write it as 6 over 13 minus 4 over 13i. This is what's called the real part, and this is called the imaginary part. Either or will be fine with me. Same thing here. This is a binomial, so I have to multiply by a conjugate, 4 minus I. And then we're going to FOIL the top, and we're going to FOIL the bottom. So 1 times 4 is 4. Minus I minus 12i plus 3i squared. The bottom, again, just have to multiply because it's conjugates. The first, which is 16, and the last, which is a negative I squared. But again, I squared is -1, and a negative of a -1 would be +1. So the bottom will be 17. And let's see what we can do. Oh, we have an I squared here, so this would be -3. So 4 minus 3 is 1, and -I minus 12i is -13i. You can write it like that, or you can write it as 1/17 minus 13/17 I. This last page is actually stuff that we'll be doing in Chapter 1. These are the answers. I will be going over it, though, in our class, just to see if you got it right. If you didn't, don't worry about it. This will not be on the quiz. Have fun.